Welcome back to the video. In today's video, we will discuss about how to analyze the forces in truss model by using a unit load method or a principle of virtual work method. So to understand this concept, let us take a simple example of truss which is having a base 5 meter, and let us name it as ABC, and having an angle of 30 degree at point A and 60 degree angle at point B. And let us add a load 50 kilonewton load, which is going to be an external load at point C, acting vertical at point C. Okay, now let's add two supports at point A as a hinge and roller at point B. So how to start and how to find out the forces induced in this truss with respect to 50 kilonewton that we are going to determine. So in order to understand this numerical, let us make a simplification of the numerical. At the base we have 5 meter span, and let us split that into 2 half with respect to C. Since our angles are 30 degree and 60 degree, we can't solve the numerical with symmetrical triangles. So we want to divide the length 5 meter into half. So let us name it as x and 5 minus x for the point, and make a dividend of this point as a first triangle and second triangle. Now let's take this 1 and 2 triangle in such a way, split it into 2 half, so it makes easy. So 30 degree for first triangle and 60 degree for the second triangle, and both we have a CC dash at the height point. Okay, so let's begin calculating this. So apply tan theta CC dash divided by x. Over here same tan 60 degree, we can apply CC dash by 5 minus x. Now simplify this equation, we can go for it. 30 degree CC dash and 5 minus x tan 60 CC dash. Okay, right. Now in both the case CC dash is common, so let's make it as an equation. X tan theta degree now equal to 5 minus x tan 60 degree. Right. When you solve this equation, we can find out the x value. So when you solve this, the x value will be determined as 3.750 meters. Now when you substitute here 5 minus x, we'll come to know it is 1.25. Okay, so I hope it's clear now to find out the x and 5 minus x distance. So we come to know 1.25 for here and 3.750 over on other side. Now what is going to be CC dash? Either you can take both the equations or any of one of these equations. So x tan theta 30 degree C dash, or 5 minus x tan 60. So in both the case CC dash is there, so I'm going to take this simple equation. So x is equal to your tan 30 degree is equal to C dash, CC dash. Right, substitute the x value over here, so that CC dash is going to be around 2.165 meters. So after substituting the x over here, so 3.750 into tan 30 degree, we will be getting CC dash as 2.165 meter. Okay, so now we have determined the all the side part, but we could not able to find out the AC and BC. So now we are going to apply the hypotenuse triangle theorem. So let's do that. So AC is equal to square root of AC dash square plus CC dash square. Similarly, your BC distance is going to be square root of BC C dash square plus CC dash square. Substitute the values. 3.750 whole square plus 2.165 whole square. So we'll come to know the AC value near about 4.33 meters. In same case, BC is equal to square root of 1.25 square plus 2.165 whole square. Now we come to know the BC value 2.49 meters. Okay, so now we have determined all the sides of the triangles. Now the next job is to find out the reactions and now replace a 50 kilonewton load with 1 kilonewton load, that is unit load. So now replace 50 kilonewton with 1 kilonewton vertical load, that is vertical directions we are applying. Okay, now we want to find out the vertical deflection at point C. So find the moment at the point. So at A we can find out the values. So take it a moment at point A equal to 0. So making that simplification, we have a beam. So RA is here, then RB on other side, then the load is 1 kilonewton is acting over here. So resolve these forces. So taking moment at point A is going to be RB is in negative direction, I am taking anti-clockwise, into total distance is 5 meters, so total is 5, and plus 1 kilonewton which is acting vertical and clockwise direction, and its perpendicular distance is 3.750. so we are going to take 3.750. so apply that, now equal to 0. So when you solve this part, we'll find out the RB value comes to be 0.75 kilonewton. Now we know RA plus RB is equal to 1 kilonewton, that is total reaction is equal to total vertical reactions or load, right? So from this equation we come to know RA as 0.25 kilonewtons, right? So now we are done with the numerical with RA and RB to determine. So it is done. Now what is the next? Now we can apply the method of joint for A point and B point. Now look at this sketch. We have taken joint A where it having an angle 30 degree, right? It's having an angle 30 degree. We need to resolve these forces with summation of horizontal and summation of vertical reactions. So draw the sketch over here again. Now RA is here, then C, and it's having 30 degree, and the in between angle is going to be 90 minus 30, that is 60. So initially we don't know what is the nature of the force. So what you want to assume, try to take all the forces outward. Now KAB, it is KAB. Now over here KAC. What is K? K is nothing but virtual force which we are assuming at the 1 kilonewton, right? Now resolve these forces. So let's apply with vertical reactions. So in this case vertical reaction is RA. Now resolve this force plus KAC cos 60 degree equal to 0. So we know RA, so bring it on other side. So KAC is equal to cos 60 minus RA, right? So what is RA? We need to find out. So KAC is equal to minus RA divided by cos 60 degree. So which come to know that KAC is equal to minus 0.25 divided by cos 60 degree. So we come to know that KAC value will be near about your minus 0.50 kilonewton. This is a negative, so the negative symbol represents compression. Okay, let's move on to the horizontal direction. Summation of horizontal. Resolve these forces with respect to horizontal direction. So we have KAB in same plane, then plus KAC cos 30 degree equal to 0. Now KAC already determined, so unknown is only KAB, so we can bring it out in similar way, minus KAC cos 30 degree. Now minus, already the KAC is in minus, so minus 0.50 and cos 30 degree. So minus into minus it will be plus, so KAB we will be getting about 0.433 kilonewton, and this is in tension. Right, so now we have determined the KAC, we have determined KAB members, so both members are determined now. Now the unknown is KBC, so this member is unknown, so let's go for the other joint. So taking joint B, over here the angle is 60 degree. So draw the sketch again. This is RB and this is KBC and KBA. Now the angle is, now it is 60 degree. Over here it is 90 minus 60, it is going to be 30 degree. Now when you resolve this force, it's very simple to resolve with vertical directions. So let's go with vertical direction. So summation of vertical 0, so RB plus KBC cos 30 degree equal to 0. So equating that, KBC is equal to minus RB divided by cos 30 degree. So KBC is equal to, now RB we know that it is 0.75 divided by cos 30 degree. Now KBC is equal to how much? We are going to get it as 0.866 kilonewton. This is in compression again. The negative value represents compression members. Right. So now we are done with KBC. Once you are done with all the forces, you can now move on to the tabular column. So now make a tabular column to represent this. So over here we are going to take a table. So first table member represents the truss members A, B, C and AC. The second column represents the length, which we are converting into mm, and the third column represents, that is in unit force with respect to 1 kilonewton. So whatever you have find out, it's all with respect to 1 kilonewton of forces. The fourth column represents the real forces with 50 kilonewton, how to find out. So now this 21.65 is determined by, in such a way, 50 multiplied with your unit force 0.433. So that gives you 21.65 kilonewtons. So I hope this is clear now. In the same way we can find out 43.3 and minus 25.00. Once you are done with this, the fifth column is nothing but just multiply column 2, 3, 4. Just it's a multiplication of column 2 into 3 into 4. So do the multiplication of column 2, 3, 4. Then 6th and 7th is represent the area of the section, each member section area, and E is the modulus of rigidity. If it is provided, we can take this area of the members and Young's modulus of rigidity. So once you are done with this part, now we can calculate the vertical deflection. So do the summation of all this. So we have done the workout. So the summation of the forces is taken. Now use the formula vertical deflection del is equal to summation of KFL divided by AE. So when you solve this, so we come to know the total deflection, vertical deflection at point C is divided by AE constant. So when you substitute this, AE will find out the final values of your deflections. So in this numerical I have not provided any area of sections and Young's modulus, so I have kept it as constant. Okay, now we have find out the vertical deflection. How to solve this numerical for horizontal deflection at point C? It's very simple. The same manner, now in order to find out the horizontal deflections, so to find out horizontal direction deflection, all you need to do is just add 1 kilonewton in horizontal directions, and this is going to be RA and this is going to be RB. Resolve the forces. Now find the moment at point A equal to 0. So find out RB and RA and RB. So once you're done with this, now resolve the forces with method of joint A and method of joint B. We can find out the virtual forces due to 1 kilonewton horizontal forces. And then you can add a column with respect to horizontal forces, what are the members you got. Now over here it's vertical direction, you can replace this with horizontal forces. In the same way we can find out for the horizontal deflection at point C. Right? I hope this is clear, and make a note over here. So when you take the real force 50 kilonewton at point C and you are finding the vertical deflection at point C at C, so we are replacing that 50 kilonewton with 1 kilonewton load and we are finding the sum. So when you multiply that, your 50 with K, that is over here, the step which I explained over this particular point. So we are taking 50 kilonewton load multiplying with K values. So this condition is applicable, but when your load is over here at 50 kilonewton at point C, now I need to find out the vertical deflection at point B. So in this case this condition does not exist, so we can't directly substitute the multiplication. So we need to resolve the forces for each real forces separately and virtual forces separately. So here we can directly do the multiplication in this table, but in the case where your real loads and your virtual loads are at a different point and you're finding the deflections, then this method is not applicable. So we need to resolve the forces separately for 50 kilonewton and resolve the forces for 1 kilonewton. Then we need to make a tabular column. So I hope in this video you understood how to analyze the forces and the truss members. So thank you for watching my video, and we'll discuss with new concept in next video.